Alright, so in Objective 2 about matrices, we're going to be adding and subtracting matrices and also doing scalar multiplication. Scalar multiplication, not the same thing as matrix multiplication. That is so in-depth, it needs a whole lesson all by itself. So if you're interested in seeing why I chose the pictures that I did for this objective, check out the next video right after this. It's kind of shows you that this series of pictures uses all of those things, adding, subtracting matrices, and multiplying by a scalar. So first, let's look at adding these two matrices together. Nothing could be simpler. Well, I'm sure something could be simpler, like going to sleep could be simpler, but this is about as easy as that. All you have to do is add up the corresponding elements. Like, for example, this 2, I'm going to add it to -3 and get -1. The 4 plus 2 is a 6, just going straight across. And then coming down here, the 0 plus 4, I got a 4. And the 1 plus 0 gives me a 1. And then I put it in some more square brackets. So here's my answer. Notice that I started with a 2 by 2, a square matrix, with another 2 by 2, and I ended up with a 2 by 2. As a matter of fact, you can only add two matrices together if they have the same exact dimensions. So you couldn't add a 2 by 3 together with a 2 by 2, it wouldn't work. So to add two matrices together, all of the same dimensions, then all you have to do is add the corresponding elements. That's all you have to do. So if you see this generic one right down here in the middle, I've got A plus E, that's going to go in the first slot, right? This A plus this E is going to go in the first slot. I just add up the corresponding elements. Very, very simple thing to do. Okay? So, like I said, this shows a 2 by 2, but you can generalize it to any size matrices, any two n by n matrices. Okay? So let's look at a subtraction problem. I'm going to subtract these two matrices. So when I subtract these two matrices, it's just like adding them. I'm just going to subtract the corresponding elements. Okay, so like for example, this 4 minus 2, I'm going to get a 2. 6 minus 3, I get a 3, just going straight across. -2 minus a negative, which makes it plus 4, which is another 2. 2 plus, minus a -2 gives me, no, 2 minus 2 gives me a 0. 1 minus a third gives me 2/3. And 5 minus 1 gives me a 4. And then that's it. It's done. Pretty simple, right? Again, notice that I had a 3 by 2, 3 rows, 2 columns, and I'm subtracting a 3 by 2, and I still end up with a 3 by 2. All the dimensions have to stay the same. Okay? So to subtract two matrices of the same dimensions, you just subtract corresponding elements. Very, very simple. A minus the E goes right there in that first slot right there. A minus E goes in the first slot, and so on and so forth. Again, this is 2 by 2, but it works for any m by n matrices. Okay, so the next thing is what a scalar is. In linear algebra, just a regular old real number, just plain old real number, is called a scalar. And to multiply by a scalar, just like the distributive property, you multiply every single element inside the matrix by that scalar number. Okay, it's not the same thing as matrix multiplication. That's going to be one matrix times another matrix. Here, I just have this number k. It could be like 5. That's outside the matrix. So you just multiply each of the elements on the inside by 5. It's, like I said, it's like a distributive property. Okay, very, very simple. So if I am going to multiply this 3 by 2 matrix by the scalar 4, I'm going to end up with another 3 by 2 matrix, but all of my entries, all of my elements are just going to be 4 times bigger. So I have a 12, a -8, a 0, a 12, a 4, and a 24. And it still stays exactly the same size, a 3 by 2. Easy. Okay? So putting it all together, here's one that you just have to perform order of operations, PEMDAS. You have to do the multiplication the scalar multiplication before I can do the addition on this. So let's just go ahead and multiply it by the scalar -3 right above or right below this matrix right here. So -3 times -1 gives me a 3, then a -15, a -12, and 0. Why did I cross it out? Who knows? Okay, now I can go ahead and add them together. 3 plus a -2 is 1. -15 plus 1 is a -14. -12 plus 5 is -7. And 0 minus 3 is -3. And I am done. That's it. So here are a couple of problems, 1, 2, and 3, for you to try on your own. Copy them down, write down your answer, pause the video course, and then come back and let's check to see if you have them right. Okay, let's see how successful you are. Voila. So number 1, nothing strange happens. Just add up your corresponding elements. Number 2, something strange does happen because there are different dimensions, and if they're different dimensions, different orders, you cannot add or subtract them, so that one's not possible. And then finally, number 3, do your scalar multiplication before you add up the two matrices together. Okay, so there we have it. In the next video, we're going to see how to put these matrices in the calculator so that we can do some fun stuff with those.